is about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hello and welcome to a meeting of the C++ Digital Signal Processing and JUCE study group. And as always, we have Fotis. Hello, Fotis.
Hello.
And hello, Cwits. I'm getting the right sides this time. And hello, Bo.
Hello.
Hello, how are you doing?
And finally, hello, David.
Hi.
People on the stream already know David from some guest streams in the past. You have written some code with me before. And now I have him here in real life. How amazing is that?
Wow.
In 3D.
Yeah, and as it happens, he was showing me a list of things that he's interested in learning. And in that list, I saw C++ question mark. And I guess our answer is C++ exclamation mark. Oh, I see that I actually have myself doubled on this screen. How about we change that real quick? Better. Oh, not better because then I don't see. Ah, better. All right. So, who wants to go first? Give us some updates. Go, Fotis. What have you been up to?
Okay, so let me share my screen. So for today's update, I have to share some cringe. I created some genuine cringe for you guys. You're gonna love it. This is Big Cringer. So let me explain.
Can we make that a bit bigger?
David hasn't seen this before, but this is my Behringer mixer, and I used this tutorial on YouTube. I'm gonna show you the video real quick. So this is GuitarML. I'm gonna show you the website as well. So GuitarML, of course, stands for machine learning. So GuitarML is making plugins that are simulating cabs and pedals. And they're also working on their own guitar pedal, which is essentially a Raspberry Pi that you load models of amps and stuff. So you won't need a computer to have a VSTs or even spend tons of money on an JSFX. You just have this little Raspberry Pi thingy, you plug it on your guitar, and off you go. And we have tons of little...
and what's the ML part? Is that because it's kind of...
Machine learning.
No, but in this sense, like you couldn't make these effects without the machine learning? Is that the point?
Yeah, I'll show you exactly what how it works. And I can test it with this plugin, which is called Proteus. And The funny thing is that you can use it both on actual hardware and on plugins using Reaper. And the creator of GuitarML on his YouTube channel has a lot of interesting tutorials, including one where you can combine his plugins with BYOD, which was created by Jatin Chowdhury.
Speaking of him, actually, I have two comments about the ML part of things. The first is that it can be faster to, I guess both comments have to do with being faster, but it can be faster to use machine learning for like guitar pedals and amplifiers and stuff like that. It can be faster in terms of development because you can just treat the pedal or the amplifier as a closed box and pass some audio through and see how it affects the sound. And then you don't have to like open it and see all the components, come up with differential equations for the system and then solve the differential equations and then try to optimize. You just use a machine learning model that will be faster to develop. Okay. And it can be faster to compute as well, depending on how fancy the circuit is. Doing it in like machine learning models and running very lightweight models at that can be faster than just writing code that solves differential equations and stuff like that.
Yeah, I guess I'm missing the context of
how I'll let you know about the context in a sec.
Okay, cool.
So the difference is that up to this point, before machine learning and AI became a trend and started crawling its way in our music production world, the way that it used to happen for like 10 to 15 years was to capture an impulse response of an amp or a camp by playing a Dirac spike, like from an amp to a cabinet, and then record that impulse response and then play it on a guitar convolution plugin. So you get pretty much a copy of that sound. Now, this technique that I'm going to show you, is similar, but it uses AI, so it's better. But this is how it works. So this guy wanted to capture the plugin emissary by Ignite amps. So in order to do it, you have to go to my favorite website of all time. Can you guess what it is?
Google?
No. GitHub. Close though.
Fotis has like over 1,500 stars on GitHub.
Wow.
Yeah.
As in, he starred 1,500 projects.
Let's see. Maybe I can... Oh, wait, hold on. 1,500 stars on your projects or projects that you've starred?
He starred 1,500 projects, as in he...
Yeah. Okay. All right, let's see. Maybe I can...
He dug into and got interested in...
developers.
I think I could match that.
Yeah.
Oh no, you've
1,800.
No, you've trashed me. 930.
Let's trade GitHubs.
No, I need to. I need to up my game.
Yeah, you're gonna see some stuff. Anyway, so this is the source code of Proteus, and if you click this link, I can't find it on GitHub right now. There is a separate download, which is the capture utility. And that thing has two files. This is an IPYNB file that you load on your Google Drive and you load in Google Colab. And it's this thing right here.
It's an IPython notebook. That's what it is.
Yep. And the other thing is a wave file that was created by the Proteus guy, the GuitarML guy. So this file begins with two Diracs, pop, pop, then some sine sweeps, and then another way to capture impulse responses usually, but here's the difference. Then we have some noise. The cool thing about having colored spectrograms is that you can tell which parts are noise and which are tonal, and
yeah, it's
the
cool.
sine sweep looks literally like a rainbow.
Yeah.
And then
cool.
you have some guitar playing that the GuitarML guy. He just jumped. Anyway, so what you do is, if you want to capture a plugin, you load the plugin in Reaper. For example, I did Air Windows Gringer, which is a very weird guitar plugin modeled after a pedal that Frank Zappa used. Then you render this file as a 4400 kilohertz 16-bit mono file, and then you upload it to this Colab notebook as out.wav. The numbers are something else. Anyway, and then you follow the steps, and you load up the file that you exported from Reaper, and then you press OK. You wait for the training to happen, and then instead of giving you an impulse response file, it gives you, and this is where the AI thing comes in.
How long does it take to train?
About 5 to 10 minutes.
Oh, that's very good.
Also, just on sorry, before you get there, just on the Google Colab side of things. So I guess they are lending you some servers here, and you don't pay for that?
No, you don't have to pay at all.
Right. Like
because
forever?
Yes. I just upload it here, and then I use their GPU. I do the stuff, and then I sign out. Simple as that.
I think that you could also run this IPython notebook in your machine if you download IPython and stuff.
Yeah. No, it's just, I'm just curious because like actually running this Colab Python notebook on Google Colab, I mean, it's kind of generous. Like normally you'd have to pay for this kind of thing. I don't know. It's like I wonder what the limits are.
I think you have to pay for some more usage, like more hardcore usage. But for normal stuff, I think it's free because I've used tons of collabs and I was never asked to open my wallet. Anyway.
Okay.
Cool. I'm a big fan of not opening wallets.
Now here's the thing: it doesn't give you an impulse response. All it gives you is a JSON file. So this is it. This is literally what you get and what you load in Proteus. So
those are the weights in the model. Those are like the numbers that are associated with each of the, I guess, neurons in the neural network.
So this is Gringer, the regular VST. And then this is Proteus, the Gringer that I created myself. Note that this button is on by default, and you have to put it to off in order for this to work correctly. See, they're almost identical.
Yeah.
There is a very tiny bit of difference. And you have EQs. So yeah,
Could you do a null test with that?
Yeah, let's do it now. It's gonna show a bit of difference, but yeah. So yeah, there is a difference, of course, but it's mostly in the very high frequencies.
Yeah.
Hang on, I'm curious. Did you set up multiple tracks and stuff, and I didn't see?
No, I didn't. I just put a delta on the Gringer itself, so it nulls with Proteus.
No, because it's not working on the original signal. It's working on the already processed signal, right?
Oh yeah, you're right. Let's do it this way. Boom.
Invert the phase.
Yeah, it's still not nulling. But yeah, if you don't null, the difference is tiny without a null test. I mean, the tone is generally similar, and this is optional. You can choose to create a graph that shows you how close it got to the original signal.
Cool.
and you have some notes at the end. It says that a loss of 0.2 or less is equal. I don't remember capturing one for Gringer, but it was very low. However, the thing that I showed you was something else differently, the cringe thing. And that took slightly more time. So the other tutorial in this channel, this guy is capturing his Blues JR Fender amp. That's a Blues JR, right? It's a Fender.
Blues Junior, I have.
Oh yeah, he just said it at that timestamp. Anyway.
You prepared that.
So yeah, no, I didn't. But yeah, I did. You have to set up 5 different tracks in Reaper and then adjust your volume on the amp in 5 different volumes. So you have to put it in 1%, not 0%, because the model does need something to work on. 1%, then 25, 50, 75, and then 100%. So you get 5 recordings, and remember to mute the channels like he has here, so you don't get any feedback loop. And then he tweaks the volume, and then he re-records. So yeah, he plays back that sample I showed you in the amp in 5 different volumes. And what you do is you go here. Oh yeah, I forgot to mention that you have 3 different options. 4. So if you want to create a clean or break amp or a compressor, you choose this step. If you want to use a heavy metal like amp, you use this one. If you want to use distortion or boost pedal, you use this one. I used this one for Gringer. Now the 4th one is the one where you need those 5 different controls, and this should give you some more flexibility and some more broader capture of your device. But I wasn't trying to create an exact replica of Behringer, sorry. These things shouldn't rhyme. But I find it fun that it gave me very close to what the original did when I boosted the input. So I did 5 different recordings with that mixer, sorry. And let me show you the project.
What is different between those? Are the sound files different between like amp and pedal?
Yeah. You mean the sound files are recorded?
No, I mean you showed us different options for guitar pedals, amplifiers, and so on.
Yeah.
What is the difference? Is the difference the input file, or is the difference something in how you train, or what?
Yeah, you have to use a different input file for each.
Got it.
Depending on what you want to model it. If you want to model a pedal, you use step 4C. If you want to model a clean amp, you use step A. If you want to model,
since we are here, can we dive a little bit deeper? By the way, I am fascinated by this because I wanted to learn more about how to train these things, and now you're teaching me without me having to do all the work. But can we dive into and see what tools they're using? Because there are some usual suspects when it comes to machine learning, like PyTorch and TensorFlow that I have used, and I want to see what they're up to.
Here. I think there is PyTorch. There is TensorBoard, which I have also seen on that on a different collab that allows you to create vocal clones. So TensorBoard is probably the heart of the model because it's training in epochs, which I have seen on that vocal AI.
Mm-hmm.
So, and this is the learning rate. It should be like lower than 0.02. So I did well here. And you can change this number, but I didn't figure out how to do it if you want to create an even more refined model, like 400 epochs. What else do we have here? So these are. This is the results. I want to see the tools. Oh, so we have some files. These files are automatically generated when you click on step 3, but I can't show you the installation. I think I could see it in PyTorch, but I can't find it here.
Oh well.
But anyway, you can see it for yourself. I can send you. You can download the IP1B from here. I can post it on the chat. Anyway, so what I did here, these are my recordings, 1%, 25%, 75%, and 100%. And this is just for fun. I wasn't trying to create an ultra accurate model. And there was a bit of latency, so I had to realign all the samples based on the DRAC of the original. But I think what I created was very fun and unique, and I can combine it with, like I said, the BYOD by Jatin Chowdhury or any other guitar amp really. I plan to also use my brother's guitar pedal. I found a line 6 pod in his stuff, so maybe I'm gonna capture some of this. Oh, and I almost forgot. This thing does not work well if you want to capture a reverb or delay or something like that. You can capture a compressor or an amp or a distortion, but you don't. If you use time-based effects, they're gonna cause some latency, and that's gonna mess up the results. And it cannot replicate one. A similar plugin to this is the Neural Amp Modeler. You may have heard of it. But from what I know, this only works in mono. I think you can export stereo and Proteus, but I don't know how to do it. And this doesn't use JSON. It uses its own files with a .num extension, Neural Amp Modeler. And also you have to select an AIR. Actually, there was a person who created a fork of this where they added a gain automation thing, but they removed the fork from GitHub, so I can't download it and show it to you. Bummer. So yeah. And like I said, if you choose this button, the IR button, do you see the difference? Of course, you see it's plain obvious.
Yes.
This is a default cab IR that Proteus comes with, just if you want to smooth out the output a bit. But if you turn it off, you have a very clean frequency response. And I like what I did. I'm very satisfied with the result because it's very subtle but very effective. And you can adjust the EQ, so there's that. But I mentioned this in the previous meeting, the past to future reverbs. This is not a sponsored stream, by the way. I wasn't paid to promote them. But this is how I found out about the training, because this person is making tons of impulse response captures, neural captures, using the exact same technique. And you even have, where is it? Sometimes they post the image, the one that I showed you. Anyway, he doesn't have it, so let's see mine instead. So this is what I gave them, and this is what it created. So you can see how close it came to the original recordings.
That is very impressive.
It was even more impressive when I used the plugin, because you get the same thing. But it's cheating, right? But the fact that I managed to go this close with analog hardware on my very first try is something interesting, and I want to see how I can take this in the future.
Yeah,
But
I think
like
that there is a gap in the market now, because I don't know how the NAM thing is doing, but this IPython workflow, it's very cool, but it's not the most ergonomic. So if you could do even the training in the DAW, that would be very cool. You could just put the plugin in read mode and pass some audio through it.
That's exactly what I'm planning to do. I'm planning to create both a free and a premium set of impulses. I should say impulses, I should say captures. So the free ones are gonna be the entire range of Air Windows guitar effects, because I want to have them available in this environment with EQ options and gain. Not to mention a GUI. But the premium ones are going to be, this is cringe because it's my very first model. I'm not going to play to you. Your ears are going to hurt. I tried to capture the plugin Electrum by United Plugins, which is very cool. I did manage to do it in my second and third time. And this NSFW is an actual JSFX plugin.
Do you want to know about it?
Yes, it doesn't have a naughty GUI, but the settings are naughty. You have moan, wail, scream, and squeal.
Jeez.
Sounds like you have some scars from JSFX.
No. It's that it's not safe for work. It's in the name. The name of the plugin is not safe for work.
Not safe for work. Yeah. So this is how it sounds.
No, I love JSFX. I have been writing JSFX a lot.
Yeah, we love it.
Oh, okay.
And we have worked on... Sorry, it was too loud.
But so one of the things that Jason said when he was over explaining how he modeled the clone center is that ML was better suited for one part of the circuit because it was faster. And I noticed that when you brought up the Proteus, it was like 17% CPU. So in this case, it doesn't seem to be super, super fast. Now it's down to 11, 12, but still, it's not nothing.
Yeah, and I guess when GPU audio creates their own thing, GPU audio already has their own impulse response plugin, but I cannot load their plugins in my GPU because it's not supported. It's an old GeForce. I need to have a GeForce RTX model.
Oh, so that's the other thing, right? They need to be running these models in the CPU because, well, as far as I understand, running real-time audio in the GPU is not a good thing because of latency. All that copying of audio into and out of the GPU is no good. So I wonder how they're addressing this.
GPU audio is exactly doing that to avoid high latency. Oh, wait, that's not the website. GPU.audio, sorry. That's my retro thinking. Have you noticed how many people, instead of typing the URL, they are going to Google and then they typing the thing that they want to see and then they go straight to that? So what is the point of opening Google just to type YouTube and then going to YouTube instead of going here and typing youtube.com? I just don't get it. It's
guilty as charged.
I do that.
Come on, people. Come on.
I'll tell you why.
I feel like a boomer right now.
Well, at least I press return on the keyboard. I don't press a button on the GUI with my mouse. Does that help?
Well, for YouTube specifically, I have a shortcut for searching YouTube. And I'm normally searching for something. So I don't, YouTube specifically, maybe not. But I do that for many other websites. And it's mostly because I make mistakes when I type all the time. And Google will correct them and just...
And what if you have a mistake and you go to a phishing site by accident?
Wow. That is actually,
Google will save your...
Yeah.
Yeah, We will save you on that one. So there you go, Fotis. There are actual good reasons to do it.
Yeah.
Deal.
Okay, I stand corrected.
No way. Okay, so GPU audio, how are they doing this?
We can't know because they're not open source.
But do they explain anywhere? Like, we are doing this by the means of?
They used to have... oh, there you go. So they're using around hundreds of tracks within 1 millisecond of latency without taxing your CPU, eliminating audio dropouts.
Well.
So they found a way to do it. We don't know how, but they did.
Well, they probably explain it somewhere. But
Mantra has a GPU audio one. I have showed this in a previous meeting, and it's an amazing sampler created with HISE. I love it, and it's so fun. And also Vienna. Anyway, so I digress. Nice. Anyway, so did I want to show something else? So yeah, what I said, I'm gonna create Air Windows clones of this in Proteus, and just so I can give users an alternative. I'm sure Chris will love it. I'm gonna send it to him too. And the premium one is going to be some cringe. I'm gonna create some very nasty plugin chains and also combinations of my plugins and the mixer to create some very nasty guitar things. Already I did something. This is not the cringe one, but it's... And this is only the beginning. I'm gonna do cringier ones. And I could also combine different Proteus chains together and then just export an impulse response so people don't have to actually load Proteus. They could just have a wave file of this Dirac, and off they go, right? It's the next best thing.
Got it.
And after all, there are a lot of free impulse stuff like Melda Productions M-Convolution Easy, which is free, and also Convology XT. Those two are free, and they're great for people who want to get started with IRs. Oh, and also Nadir, by Ignite Amps. So you can have this, or you can have Proteus. Anyway, I digress. So this is my update for today. And if you want to know more, check out guitarml.com.
Awesome. Yeah, I was very interested in this when I started doing that whole detecting screenshots of code with machine learning and stuff. I was interested in learning. I knew about GuitarML, and I was like, oh, I need to check out how they are doing it. And now I know more about it, so thanks.
You could create, I would like to hear you create your own models of your hardware. You do have some hardware, right? Like some hardware, some amps or some mixers. Then you have something like that?
I don't have any amps or mixes, but what I'm interested in doing is doing a DIY amp, and I could model that. It could be fun.
Oh my God, that would be even more awesome.
Yeah, there are some relatively straightforward models or schematics that you can follow, like in, what is the name of that website? Smash something? Circuit Smash?
Oh, yeah.
Something like that. And they have very simple relatively simple schematics for amps. They start very simple and they go up in complexity, but I was thinking of doing those. So maybe, we'll see.
They are as well some ready to build prototypes or something like that. Like you receive PCB and all the parts you need to build your own amplifier or whatever it is.
Oh, you could also create like a hybrid. Like you can create an amp with a Raspberry Pi or an amp like the one that Cwits said. So you can have the best of both worlds, both analog and digital.
Yeah, I think it's Electra Smash, the site that I'm thinking about. Oh. All right, Cwits, why don't you go next?
beside all of the struggle and things I have not much to share. Honestly, I am disappointed in the Qt framework because I didn't manage to get what I want from it.
Oh, that sucks.
To be more specific, I couldn't manage to draw the audio waveform from the C++ to the QML.
Oh.
There is some easy ways, but they require like double buffer using, or like you can't read the data from C++ buffer and straightforward draw it to the display. You have to copy from C++ to the QML, and then you can render. But it will take a lot of memory, so I don't want to use this approach, and don't think that it is good approach.
Does anyone have experience with that particular problem?
I spent last 2 weeks trying to find some solution all over the internet, but I didn't found.
Man, that really sucks because I have seen amazing things created with Qt. Maybe they didn't make enough documentation. Like
Maybe
I'm
I
looking at UH, I think.
don't know how to properly write requests to the Google or ChatGPT. But I didn't found solution that satisfy my needs.
Yeah, always waveform displays. They are my MobiJig. I tried to write a waveform display in JSFX and I succeeded, but it was a ride. It was difficult.
So yeah, for past 2 weeks I was looking for other GUI frameworks that will fit my needs, but there is problems with that as well, and I discovered that my Raspberry Pi doesn't work with the multi-touch touchscreen.
Oh.
It is like working, but only with single touch, not couple more fingers, and that sucks as well.
Is that a software issue? It seems like a software issue.
Yeah, looks like that. Looks like the Raspberry Pi doesn't have some kernel models or whatever. I don't know, honestly. But yeah, I didn't find solution for that one as well. Looks like not everything can be found in the internet. I was thinking in opposite way. But yeah, I found one pretty nice GUI library that is working like without any Windows Manager on pure frame buffer in Linux.
Oh.
So it could minimize the how it is called, the CPU power needed to render whole GUI thing. It's called LVGL, and I just a couple days ago started to experiment with it. So yeah, funny, not very funny. And it sounds very short.
All right then, all right. Well, good
Slow
luck with
progress
that.
is still progress.
Yeah,
Right.
I hope-
Yeah, negative experiences are experience as well.
The truth is that I never reached the end of MobiJig, so I don't know how it ends, but I hope it ends well for you, Cwits.
We will see.
What is
more
Moby Dick?
update.
I've never read it. I just heard of it.
Oh, there is this person who is obsessed with finding MobiJig. I think hunting MobiJig and killing MobiJig, which is a whale.
Strange name for a whale.
Yeah.
There's Moby
It's a
Dick
huge whale, yeah. A white whale.
Moby Dick and Free Willy.
Oh,
that?
no, that's a different whale.
Okay. Oh.
Free Willy is a killer whale. It's black and white, Moby Dick is like a huge white whale.
Okay, but both phallic named whales.
Oh well.
Yeah, and it's traveling that both Free Willy and Moby Dick are considered to be kid-friendly.
Yeah.
And I mean, Free Willy is a family movie, but Moby Dick is like a more for teenagers. I don't know, because it's kind of depressing. I don't know if kids with...
Oh,
would
it's
like
depressing. So in the end, the captain doesn't get the waveform display to work.
If you want to listen to Moby Dick instead of reading it, the band Mastodon has created an album based on the mythology of Moby Dick. It's called Leviathan, and all the songs are telling the story of the book.
And there's this Led Zeppelin song as well.
Oh yeah.
Is it worth reading?
There's a
I guess
film.
it is, yeah.
There's a black and white film.
Mhm.
I haven't seen it. Maybe I should.
Doesn't.
It's
I think I
lovely
read it
when
once as a
you
kid.
can watch the movie instead of reading the book for the exam, right?
You can listen to the album. That's
You
even
can listen
better.
to the album instead of reading for the exam. Amazing.
Ask ChatGPT for summary.
ChatGPT knows all the books.
All right. How about we go next?
Yeah, go ahead.
1 second.
Yeah, so-
I have one more update.
Oh, you do?
I
I thought that you always
It's
say,
about-
"Oh, I don't have much," and then you do a lot of things.
That was the smoking gun.
it is about our meetings on Wednesdays because in the future I couldn't join on the Wednesdays. So,
Oh.
or you can do the meetings without me, or we can rearrange somehow to the other
Without
day.
you,
Like-
never. Let us know when you are
we can
available, and
rearrange.
we'll work something out. Okay?
Okay. Thank you.
Alrighty. So let's dive in and show our update. So for the EWI that I was working on, I'm still working on that. You have seen me working on it last week on Monday, and we don't have any updates after that stream. So let's pause that and work on something else, right? How about we try one of the Project Euler problems in C++?
Sounds like fun.
And yeah, and then
Let's-
you're going to fill
Let's
in your
embarrass
like.
ourselves. Let's go.
I need to write some C++ soon, so we'll do just that now.
Also, I load after your and Bo's update, we can play the game if you want. I just loaded it. The signal state.
Sounds good. Sounds good.
Okay.
Also, by the way, just so you know, I nerd sniped Leandro today. Which, if you don't know what it is, I also didn't know. He actually sent me the XKCD, but it's basically where you you give an interesting problem to the kind of person who gets interested in interesting problems, and then their whole life is taken over by the interesting problem, and then they can't stop thinking about that problem, and then
Oh god, that's nerd sniping. All right.
yeah. And we have been discussing a problem all day, which I've tried many times to solve and have failed, and now Leandro is in the midst of solving it. So it's quite interesting.
Well,
But it would
we
be
are
nice-
solving it together.
Yeah, it's actually quite fun. You know, it's quite hard to find somebody who you can bounce ideas off and will listen. So yeah,
Yeah.
it's working quite well.
And we thought
I
about
just
doing
sent
that
my-
problem in the stream, but it is kind of a difficult problem to wrap your head around, even to understand what the problem is.
Yeah.
It takes like a solid half hour until you work through some examples and you figure the problem out.
Yeah, this will be a welcome respite, but I bet I'm gonna get nerd sniped again, and then I'm gonna have 2 snipers. But that's fine. Let's see what we got with Project Euler.
How many points do you get for programmers or computer scientists? As physicists are 2 points,
We're not-
mathematicians 3.
But we don't know. We have to meet the nerd snipers.
Did my demonstration of GuitarML count as nerd sniping?
Yeah,
because now you're interested.
Yeah,
And you're gonna fall in the rabbit hole of tone shaping and narrow lamp modeling.
we're the vulnerable targets here. We're like the victims.
I just posted in the chat my favorite XKCD, which is about audio files.
Okay.
Nice.
I will check that out, but right now I am copying and pasting things to do the setup. And as I am looking into problem 10,
What is you have a make file for Project Euler?
yeah,
Oh, yeah,
because I'm
C-
doing C++,
C++.
and I could have used an IDE or something, but I thought it would be nicer to really
Yeah, I've never
understand the build process.
I've never used make, so
Oh, all right. So we can quickly go over this. And I guess since you are like leaning forward, I will do this.
oh yeah, that'd be helpful. Even more,
How about that?
a little bit more. Yeah, okay. I can work with that.
All right. So a make file in a nutshell. You define a file. Let's say that you want to generate david.txt. David.txt will be based on like Leandro.txt. And the way that you go from david.txt to leandro.txt is by, I don't know, by... Is there a programming... is there something called tag? No.
So you
it's not
define your
installed.
output file and your input file in the first line.
Yes, and then you define how to go from David
Yeah,
to
so you
Leandro.
could
So
just
let's just
cat.
copy
Yeah,
or catch
yeah,
or whatever. We'll copy.
And it's just like run in the bash environment or whatever environment you're in.
Correct.
Okay.
And well, there is one little trick you want to know about the syntax. This is a tab. Spaces will not work.
Well, they say that tabs are more friendly for accessibility reasons. So
I don't want to get into that. But anyway,
Not sniping.
something to be aware of. And then you, well, I guess in our case, we will have to generate a file here. But please stand by as I get into the folder and let's echo.
Be right back.
All right. I will echo this into that file.
by the way, I think the video feed is holding out quite well.
Yeah, well, you can see that the responsivity here in Visual Studio Code is not excellent, but
No, I mean the camera hasn't died.
oh, true. Yeah, we are still here
Still
and
working. Which
yeah,
is pretty good.
the thing that was supposed to keep the camera on is it has crashed. So go figure, the camera is still working. Great. I'll take it.
Okay, cool.
But it may turn off. Anyway, so now I have leandro.txt and I can make david.txt
Makes sense.
and it will run that file. Now, of course, you can have a chain of dependencies where Leandro generates David, which generates Fotis and so on, and then it will know.
Can you make a recursive dependency?
I don't think so. I don't want to. No, I don't think so.
That'd be fun to break make. Okay, cool.
Yeah.
All right, high level.
And it is smart enough to not rerun if you have a file that has a newer date than...
How do you specify multiple inputs?
Oh, just put them like this.
Cool. And so then it like will diff those multiple inputs.
No, it will not do any smart thing. It will not diff. It will just look at the date on these files.
Updated at, yeah.
It's going to be looking at the update
Cool.
on these files. Update date on these files. Anyway, so as I am explaining all this makefile thing, I'm sure that at this point, Bo has already run this and he already has a solution from ChatGPT for us.
Oh, I see. That's cool. I see you do a ChatGPT one verse every time. Yeah. Well, you said you've only done 17, first 17. So probably this.
No, actually 9.
Oh,
I have
yeah,
done
first 9. Yeah. Okay. The first 9. Should we go a bit more hardcore or should we?
No.
Okay. Let's do them in order. All right.
Because every time, even when we are doing simple problems, we end up learning something about C++. For
That's
instance,
nice.
there was one problem that was maybe not this one, in which instead of having ints, or maybe I had ints, but ints were not large enough, so it was wrapping around, overflowing, and I was getting the wrong answer. So even with the simple stuff, I'm already learning about C++. So let's make it simple,
All right.
shall
Okay.
we? And I guess I will keep this line as well, so we don't have to rewrite how.
Oh, you should try this with Copilot. It would be even worse.
What do you mean?
Like it would, like you'd be like starting to try and write it, and then it will show you all the answer, but below. Anyway,
No. I don't want that.
Okay.
Let's go to problem 10, the summation of primes. The sum of the primes below 10 is this. Find the sum of all the primes below 2 million.
Mm-hmm.
All right. How would you get started?
Prime. How do you know if a number's prime?
Well, that's a good way to start.
It can only be divisible by 1 in itself, right?
By 1 in itself.
Yeah. So, I guess you just have to try and divide it by all the other numbers.
That's a good way of going about it.
But probably C++ has a library where you can generate primes.
Ah, interesting. I like where you are going. See, I was just going to start writing a little snippet that checks for primality. In fact, there are already snippets like that in previous answers because prime numbers show up a lot in Project Euler. But if it is in the standard library, I will take it. But if it's something that I have to install, I will not because it's complicated to bring dependencies into C++ projects.
But also, I mean, one of the curious things about mathematics or number theory is that there is no known way for generating primes.
No, there is.
Oh yeah?
Yeah, there is one
but
that
there's no pattern to it, is there? Isn't that the whole point? That the Euler's spiral or whatever?
True. It is true that it is difficult to determine if a number is prime or not. I mean, cryptography and everything depends on that. But if you want to generate all the primes in a relatively fast way, you can use this, the sieve of Eratosthenes. Eratosthenes. And if you want to generate very large primes, so you would have to run this for way too long to generate a large enough prime, like for instance for cryptography, you can generate probable primes with a high degree of certainty using other techniques that I'm not going to get into right now, and I will not get into them because I don't know them.
I do remember sieves and primes, but I thought sieves were a data structure. But talk me through how this works.
Oh yeah, this is just the process of filtering, right? This is what this means.
So you just generate all the multiples of 2, all the multiples of 3.
Yeah, exactly. You got it. So you start at 2 and then you mark all the multiples of 2 as not primes.
Oh yeah, this is a way better way of doing it. Yeah, of course.
Which will, of course, mark a lot of numbers, and in this animation it's kind of slow. So I will go through the next part. So when you find a number that is not marked, it means that that number is prime. So you take all the multiples of that out of the way. So you take 6 and 9 and 12 and 15 and so on out of the way. Then you go to the next one. That's marked, so you skip it. Then you find 5. If you found 5, it means that it's prime. So you take all the multiples of 5 out of the question. So 10 and 15 and 20 and 25 and so on. And then you go to the next one. It's marked, so it's not prime. You skip it. Go to 7. It's not marked. It's a prime. So you take all its multiples out. And then you keep going. And you will be generating all the primes. And you're doing that in a relatively fast fashion.
Well, to my point, though, this generates all the numbers which are not prime, thus leaving the ones which are prime. But there's no way to generate primes. Unless there is another way that I don't know about. Is this the best we got?
Maybe not, but this is something that I can explain in 2 minutes and you get it.
Yeah, 100%.
But I'm not sure if we should use this because...
what was the question?
Because we need to generate all the primes below 2 million. Oh, so I guess we can use this. I thought it was the first 2 million primes, but it's all the primes below 2 million. So we can generate an array of 2 million positions and start crossing them out. Do you want to try and implement this?
Sure. Yeah.
Seems fun.
Yeah, sounds like a good idea.
How about you all? Are you interested in seeing us implementing a sieve?
Okay, do we have sets in
Absolutely.
C++ standard library?
Yeah, let's just first try and answer real quick if the standard template library comes with a prime number generator. And it seems like the answer is no. And I hate using this website, but let's go.
Oh, it's the worst.
It is.
It's community based, but like.
I'm just trying to see if there is anything like here is. No, it's implementing this.
Don't read it. Don't read it.
Oh yeah, skip it.
Oh, let's just do
But
it.
but it doesn't come with the standard libraries. Right?
Yeah. Okay.
We can ascertain probably, and oh, this is again that,
Fast one.
but probably very fast.
It'll be interesting to read how it does it. But anyway.
Yeah, it's probably using CPU tricks and stuff. There is always things like that.
I would be curious. Yeah. Anyway, I mean, just like technique-wise, whether there's something more efficient.
So what you want is actually an ordered set, right? Because if it's just a set.
So what I was thinking was you have a set of all the numbers below 2 million.
Mm-hmm.
That number, because some of them you don't need to remove them twice, right? And then you iterate all the multiples of 2 up to 2 million, and then you just keep removing from the set. And then, for example, 6 is both present in the multiples of 2 and 3. But when you get to generate it in 6 and you go to remove it from the set, it will already be removed, right? So the set will decrease in size until it's just left with. Can you think of a better way?
I'm thinking of how about we generate a vector of 2 million positions, and each element in the vector is one bit, and then we just flip the bit. So like marking it as a multiple is turning the bit on, for instance. And then when we walk over that position in the array or the vector, then we look at the bit. Because we are using C++, we should use like bit masks and bit manipulation and stuff. Whoa.
Well, if we want to use a bit mask, then we should use a bit mask. Shouldn't we just make a very massive integer rather than a vector?
Well, there is no data type in C++ that is a number of 2 million digits or 2 million bits.
So you do have to use a vector.
Yeah, let's see if C++... We are so over-engineering this, I love it. C++... Or really...
Probably, how do you do a massive bit mask in C++?
I have no clue, but let's C++ bit array or vector. I'm sure that there is some kind of data structure for this. Bit set.
Yeah.
It's getting there, and this is a trustworthy source. Store bits, elements with only 2 possible values, and it emulates an array of booleans, but optimized for space allocation. Generally, each element occupies only 1 bit. There you go. That's exactly what I said.
That is exactly what we want. Yeah.
That's exactly what we want. Can I get like an example of how to use this?
Allocate how much.
First of all, what do I need to import?
Copilot's for. And it's in the standard library. It's pretty decent.
Yeah, and I guess we are importing this.
Look inside algorithm. Algorithm's bound to have a prime number generator.
Let's see. No, it's more like for array manipulation and stuff.
Okay.
Yeah. Has some cool stuff in
It has
there.
some sorting, some heaps. Okay, that's actually pretty small. Okay. Fine.
Oh, lexicographical compare. That's cool. All right. But no, we are doing our own here. So I will include this.
Very nice.
It's difficult to select, though. All right. I'll do it this way.
Yeah.
And
you don't need to do like namespace stud or anything like that.
Well, that's a thing that when you're using like std cout, you could say namespace std and then cout is going to be available as a global thing, and I don't think that's a good idea.
No, I more meant for the actual, when you're doing the include, do you not need to specify stud, or if you don't specify stud, you need to specify
No, I don't think you need to do that.
Okay.
std is like the namespace for the stuff that comes with the standard library, so including bitset and iostream and everything else, and even algorithm.
Cool.
You see that probably in the algorithm documentation it will say, oh, no, it doesn't. Oh, well.
Okay.
You live, you learn. But let's see how to use this.
Yeah, they need to provide examples.
Yeah, I would love to see.
What's Copilot's for?
This is what GitHub Copilot is for examples?
Yeah, it's amazing. You just type like, what you would do is you type in Copilot like, create bit set of 1,000, and then it would, as a comment, and then it would just do it, and then you'd be like, okay, that's how you use it.
Okay. Well,
or Google it.
I will Google it. I'm Googling it. And is this going to help?
Okay, there we go.
Not really, because it's not using the bit set.
Well, no, it did say bit set.
Example, bit set.
Here we go.
Okay, here we go. Here we go. And this is the size. Geez, that's amazing. I love it. I'll even copy and paste it.
Well, the one below had the size.
No, this is the size. And in
Oh,
our
it's
case,
there?
it's 2 million. That's all there is to it.
Nice. Very cool.
Cool. And for...
But it hasn't been allocated yet.
No, it has.
You just declared the size. I thought, okay.
Yeah, that's how they do it here. See?
But the line below, you see, you actually call it with the number. Oh, that's the size of. Is that the type? Actually, you've given it the generic type.
No, the bit set is going to contain bits.
Oh yeah, that's true.
I don't know. But I see that by default, if I don't provide a parameter, it's generating an array with 8 elements. So I'm happy.
Yeah. Okay. All right. Makes sense.
And then let's see real quick how to find something in the array. You can do dot size, but that's on a string, so that's not the same. Well, let's just assume that you use it as a vector and it's going to work. So let's say that for... is 2 million going to fit into an integer? I'll never know.
Do they not have like a
yes.
sort of... Okay, well then that's fine.
So what we want to do to generate the primes is to loop from...
To the square.
Actually, we start at 2, right?
That's what square root, sorry, up to the square root, yeah.
And I guess I'm going to put 2,000,001 just so we don't have an off by 1 error.
Yeah, fine. Well, but that might produce an off by 1 error in the other way.
No, we have an extra element, and if you don't do anything with it, that's fine. And if we do something with it, it's okay. I just want to be able to use this number as an index into the primes instead of having to subtract.
Oh yeah,
one,
okay, sorry, yeah.
So anyway, so we start at 2, like we saw here in the Wikipedia animation, and we go up to what I'm going to call the maximum, which is going to be 2 million.
Shouldn't it be the square root of 2 million?
That's an optimization.
Okay.
And we talked about this optimization before. It's nothing fancy, but
Okay, fine.
So if the number is less than or equal the maximum, less than or equal, I think that makes sense. That's what I want, right? Or actually, let's read what do they say? Below 2 million. So less than. There you go. How about that?
Well, it doesn't matter, does it? Because we're not going to go all the way anyway, so yeah.
Oh, and I need to mark that 2 is a prime? No, being a prime is 0. That's the default state. By default, we think that the number is a prime until we mark that it isn't. So.
Oh yeah, that's true. Which is why the 2,001 might be an issue.
No. It's not an issue, trust me. It's going to be all right.
Okay.
But the thing that I want to say is that this is not a vector that tells you if the thing is prime. We are actually able to tell if it's not prime. I guess I will keep primes as the name, but we have to remember that 0 means prime and 1 means not prime. Anyway,
okay.
So we are going to go over all the numbers, and if primes at number is equal to 1, it means that has been marked. So we skip it. And otherwise, we'll need to loop again. But we are going to use a while loop this time because we are going to be like the opposite of a prime is a composite, so I'm going to call this a composite.
I should call it composites then, maybe. I don't know. Yeah, okay.
And I'm going to start with this, and I will have a multiplier, which will be, I'll start at 1, or maybe 2 to keep things simpler. Yeah, you don't mark the 2 itself off. You mark 4 off, right? Because 2 itself is a prime. So I'll start with the multiplier at 2, and while the composite is less than the maximum, I will do two things. I will take the primes at the composite and mark it as a composite, and I will take the multiplier and I'll add 1 to it. How do you like that?
Well, before you add the multiplier, you need to mark all of the you need to update the composite, right?
Yeah, I don't want to do it at the composite. I want to multiply the multiplier here. Thanks for catching that.
Yeah.
That's what I want to do. And, well, actually, no, because I'm comparing this. So I want to do the multiplication again, I guess, here. But this is slow. We are talking about C++. We want to make it fast. So let's think about this for a second. I'm actually multiplying the number by the multiplier.
I would maybe do like a while true loop.
Or a do while loop?
Or maybe not do while. Well, it could be a do while.
Nah.
But just like because a while true and then just break when you get to that case, because then you don't need to do like the initialization and the...
I see your point. So let's do it. So we will do the composite. It is the number times the multiplier. And then if the composite went over the maximum, then we break. Otherwise, we do this with a composite.
Yeah, I like that. And then maximum is 2 million. So yeah.
Number times the multiplier is the composite. If the composite is over the maximum, break, and then mark it, and then add to the multiplier. I like that. I like that.
Shouldn't have any out of bound issues there.
Yeah, and also if we have reached here, it means that this number is prime, right? Because otherwise we would have made this.
Yes.
So how about we just plop a sum here, and
you surely algorithms has got that. Oh no, that's nice. Yeah, perfect.
And it's not liking something. Oh, it didn't like the indentation. That's all right. So then at the end...
Are you sure, guys, that integers is big enough to store that big numbers?
Good point, because it is big enough to store the 2 million, but perhaps not the sum. So the sum is going to be a long.
Wait, hold on.
Remember our previous...
Oh, is it the sum of all those numbers, right? Okay.
Yeah, so this number will be larger.
It's definitely not the count. It's the sum of all the numbers. Yeah, it is sum. I remember now. Yeah, okay, yeah, might be. Yeah, just chuck a long in there.
So I will first run this with all the primes below 10.
Oh, I'd quite like to see the ChatGPT code.
We will. And we answered the right answer. in 0.3 seconds. Not bad. Not good.
No, that's pretty bad. But then it is a very computationally expensive thing, I suppose.
No, not really. Up to 10? No.
Oh, wait, what? This is only up to 10. It's amazingly slow. I guess that's is that the compiler time as well?
No, I'm only timing the execution.
Wow.
Oh, well.
I mean, it doesn't matter, but it seems...
Or is it in milliseconds?
Well, yeah. Yeah, that would make more sense.
Oh, 10 is too much.
1.
That is in seconds.
Okay.
So
That's
we are
weirdly
talking
slow.
about like, 400 milliseconds for computing this. Sounds like a lot. Is it like allocating this and that's slow?
Oh, it's because we are allocating...
But hang on. No matter how fast or slow this is, we got this thing right first try. High five. That is very nice.
Yeah, very good, very good.
So all we gotta do is take the
Okay.
maximum to...
No, make the bit set 10 out of curiosity, the size of the bit set, just to see if that's actually like...
I will make it 11.
Yeah, sorry, 11. Oops, your timing's sleeping.
It takes 3 seconds to sleep for 3 seconds. So now you know. Yeah.
Yeah, so maybe it's just importing IO stream and bits.
Oh, was it timing the... It was timing the compilation as well. It is blazing fast, forget about it.
Okay, forgot.
And what do I know? The timer is already running. Hang on. I think that what Bash does is it starts all the programs in parallel? No, it must not, because this needs to succeed for this to even run.
Yeah.
Oh, well.
I think...
What the hell just happened here?
I think it might be like some kind of caching thing.
Oh no! Do you think that it's caching the loading of the program?
Something like that, yeah.
1, 2, 3. 1, 2, 3. And now? Well, this one doesn't count, okay? This is our final answer. 100 milliseconds.
Yeah.
150 milliseconds on average, let's say.
Okay.
But this is our answer. Now let's see if our answer is right. And for that, I will bring Safari, because on Safari, I am signed in, and it's going to show me the answer. And it's going to say that it wants Safari to be my default, but it won't be. Oh, I'm not signed in anymore. That's what happens when you don't use Safari for long enough. So excuse me as I sign in. And
this is the hardest bit about Project Euler. Getting those things right. Oh my god. I have no idea. Okay, this one's doable.
And it was not even my password that is wrong. It really is the CAPTCHA.
Oh, you're not typing? 815, you did it wrong.
Oh no! Finally!
All right, let's see if we got it.
And this is our answer. And
wait, hold on.
Yeah, we got it right. High five!
High five. But why aren't you meant to submit it rather than read the answer?
Yeah, let's submit it first.
What do you say? What did you say?
Like, when I've done it before, this like long time ago.
Oh, you had to submit the answer? No.
You completed it back before records began. So you've done this before.
I have done this before in
a long time
Ruby, like 13 years ago.
Yeah. I also did some of these like 13 years ago. Okay, cool. That's why you can see the answer.
Also, Bo posted the ChatGPT answer in the chat, but don't look at it.
Don't look at it? Well, that's what we are going to do next, because we got the right answer.
Yes,
and
you're going to see it later, after you do the human one.
Yeah, no. We finished. It's working.
Okay, sorry.
So,
I wasn't paying attention.
So the ChatGPT script is
that... It's sagging. My new tripod doesn't seem to hold as well as I would like it to.
I was actually curious to see the ChatGPT C++.
Well, that's what we are going to see now. And thanks for Bo for
I mean the script, which actually... Is there not
well,
a script which checks it? Is that not the thing?
No, Bo just asked for ChatGPT, please give me the answer for Project Euler problem 10.
Oh, he didn't actually...
In C++.
In C++.
But he didn't even give it the, like...
The prompt, no.
Really?
Yeah.
That is shocking.
At least that's what he did last time, and he said in the chat that he was away from the keyboard, so we can confirm with him later, but I really think that that's what he did.
I'm back.
Oh, so that was the
go.
prompt, right? Just give me the answer for problem Euler 10 in C++. Could you code the number 10 problem in C++?
Wow. So it's really just doing it from memory. I thought you were at least giving it the prompt of like what. Yeah, that's pretty crazy.
By the way, one day when Bo couldn't make it in the live stream and I don't have GPT-4, Bo is using GPT-4. So instead we thought of using H2O GPT, which is a bundle of open source GPT robots. 6 robots, in fact. And most of them got the answer wrong.
Wow.
Oh, syntax error.
No, not really. It's just a warning. I think it's probably because of my compilation settings.
Got it.
Because it's a C++11 extension, and I didn't tell it to use C++11, but in any case, it compiled anyway. And it is generating the same result, and in about the same time, I want to say.
Yeah, it's about... Wait. Yeah. Yeah, I think that is about at the same time. Let's have a look at the solution.
Yeah.
I can already see one premature abstraction.
Yeah, function to implement the sieve of Eratosthenes. Well, they are doing something that is theoretically worse because they are accumulating all the primes instead of using all the primes as they come, like we are. Because we are not creating an intermediary vector of integers. We are using a bit set to implement the sieve.
Yeah.
But I would argue that our version has the edge in terms of like performance and not in terms of reusability.
Ours is beautiful. So yeah, that's both we're allocating everything up front. There's no dynamic resizing. And secondly, we're using a bit set, which is going to be a lot more efficient.
They are using a vector of booleans. I think it is about the same in terms of like size and stuff.
Maybe, yeah. Oh, I don't know. We don't know how. I mean, it's optimized for space, right?
Yeah, I think that the vector is optimized for space just the same. And this is just a bit.
Yeah.
So not really sure what's the point of a bit set, but we are using it.
We can read the source code.
Let's see what it says. Well, there is no comment.
Is this the... It's pretty cool you got VS Code configured to work with C++.
Oh yeah, it was not even that hard. There is... well, there are many extensions, but if you just Google for like extension, or if you search here for C++ extensions, it's going to use a Microsoft extension that, in my experience, didn't work with the jump to reference all that well. But CLangD works very well.
Okay,
and
good to know.
It is a bit more challenging to configure if you have a complicated project, but if your project is just using the SCL, then it's going to work.
Yeah.
All right, so I don't want to get into that. I'm scared.
By the way, I just checked out H2O GPT again, and they added a new model whose cutoff was last update was in 2023. So that's, I think, the closest thing to GPT-4 that you can get for free.
Okay. And what is the name of it?
It's called H2O GPT-4096-Llama 2-70B-chat.
It does have a ring to it. Anyway, so I think we found the answer. The advantage of, oops, and then I scrolled and I lost the answer. But the advantage of using a bit set as opposed to a vector of booleans is that you get operator overloading. And you can treat them as one number if you want to do bit masking and stuff. So this is how you do a giant bit mask in C++.
Wait, sorry, I was thinking when I saw this, like, oh, they're using bit shifting to make this more efficient. And
bit shifting, yes. By the way, do you know that meme with the bit shift that Chris for my Windows did? Because YouTube thought that he was cursing when he said bit shift because it sounds like, you know.
Son
and so he had to take, yes. So he had to take a long pause. So bit shift. Or he just wanted to say word length.
Yeah, no, I think that what this is, well, I don't think
it supports some operators, so you can actually treat it like a big bit set.
Yes, I do know that in C++ this operator stuff is
overloading, right?
So that you can just use like primes as if it was a number. So you could say like
what
primes.
methods does it have on it?
What?
What methods does it have on it? The bit set, like. I know you can...
all the usual suspects. You can AND, OR, XOR, shift to the left, shift to the right. You can shift everywhere.
Look, flip, for example.
Oh, yeah. So this is like XOR with a bunch of ones. Cool stuff.
Cool. All right. Nice.
So now we know.
Now we know.
Anyways, ChatGPT doesn't know because it's using a vector of booleans. But what does it matter, right? We are not using any of that fancy stuff. We are just accessing anyhow. So what have we here? It is probably the size, and they are using +1 as well. Great minds think alike. And by default, it's saying true. I thought about doing that. I thought about having a default here so that the default would be 1, and then the primes, we wouldn't have to do this. And then we would do like equals to 0, you know. I thought it would be more clean that way.
Because then it would be semantically more accurate, right?
Yeah. 1 would be true. But anyway, that's what they did there. Cool stuff. Then they are setting the first 2 to false because 0 and 1 are not primes. That makes sense.
Oh, they don't have any dynamic allocation either. They are actually just allocating out front as well.
Well, so they need to do something for this return value. There. So this is dynamic allocation. And they're doing something that I would consider a bit silly. They are iterating over the numbers to do the sieve, but then they are iterating over the sieve again to collect the primes. They could have just pushed back right in here.
Yeah, that's true. This is
Or
maybe
right
easier
here,
to read, though.
You find this easier to read?
Maybe, because it's like, okay, this block of code could have a comment. And it said this is like, you know, zeroing out all the primes and not primes. And then this block of code just sum it all up. Or is that what it's doing?
No, it's not even summing it all up. This block is marking, and this block is collecting. But when you get to a number, you know that it's prime. There is no point in going over it again just to collect. This is just busy work. And this is what we did with this line here, actually.
Yeah, let's go back. So if it's... Yeah, you just do that at the beginning, before that second for loop, right? Or after it.
Yeah, if it is prime, then you're collecting, you're marking. This is marking, so it's looping over all the numbers and marking them. You could just have pushed back right there.
Yeah.
Right?
Yeah, 100%. You did a way cleaner solution. So then you just generate the primes and then you sum them up.
Oh, they used long. They were afraid. Yeah. So you just generate the primes and you go over them and sum them all up. That's easy enough.
Yeah. Nice.
Okay.
Nice. Okay, so 1 to humans, 0 to ChatGPT.
Actually,
do you have the score?
Well, I don't think it's like a score that I keep, but generally the feeling I get is
because you always win, so it's easy to...
Well, it's hard to tell because I'm biased because I am me and I wrote the other version, and we are we and we wrote the other version. But I would say that I like that they have an abstraction that we could reuse if we needed primes in other contexts. I like that.
That's true.
So that's something that...
And more than likely, Project Euler we will need it.
True.
Again.
So you could start building yourself a little library of useful things for Project Euler. I also like this because it is just the simplest thing that can work. So if I was to explain how to do the sieve, I would perhaps... I don't think that this adds a lot of complexity. So...
Yeah, I think the only thing is I agree maybe to either rename the primes or have it as 1 by default. That is the only thing.
I would like that. I would like that. And I guess another thing about this is that if you're really going for performance, instead of returning a vector, I would allow you to pass in a lambda to reduce.
Oh, you could have a generator, yeah.
So,
actually, no, you couldn't have a generator.
No, what I'm saying is you could, instead of collecting all the numbers into a vector, then to immediately thereafter destruct the vector and get the numbers out, you could pass in a lambda into the sieve of Aristotle's function, and that lambda would be doing the reduction already. So, because this is a reduce, right? We are reducing over the primes and getting a sum. So you could pass in a reduction function. That's kind of, I don't know. I don't know.
It is. It would be an iterator actually. It would, or like an iterator type. You could actually, implement an iterator. Do you know how to implement iterators in C++?
I don't know how to implement iterators in any language. I always have to look it up.
yeah. But like you see, if you go down, you see that line 33. That is probably what... Is that how iterators work in C++? I think that is the syntax, yeah.
Yeah, I suppose.
So that would be pretty cool, actually, if instead... syntax-wise, pretty sweet.
Anyway, I would say that in this case, there are pros and cons to both. And just this pushback, I think, is a clear win for us.
Yeah.
But if you disagree, you can push back on that.
Very good.
All right. So that's us. Now let's hear from Bo.
Oh, also.
Yeah.
What?
Mic was off. Go ahead, David.
No, there was one last thing, which was they still didn't need to do dynamic pushback because they would at least know the number of primes they have.
True. So that's the other thing I was thinking about.
But they may as well just put it straight in, I suppose. But
yeah, so if you are doing this, at the very least, you could count how many primes you've seen and then allocate them all at once.
Yeah.
Instead of doing dynamic allocation here.
Yeah, but anyway.
But robots, they're catching up.
Yeah, so a share screen. I have not got a lot of things to show you because all the code I've written, I've scrapped.
Oh.
It's a good feeling. I love the sound of throwing plugins away. But what I do have, what I talked about a while ago, was a limiter. And it's kind of working. It's not sounding super great, but I will demonstrate the waveform for you. Can you see it? Yeah. It's on the screen. So I've implemented my dynamic low pass, if you remember that one. So what it does, it's sort of softly clipping the waveform as I'm pushing the velocity. Do you want to see the code? I had to sort of make the only complicated bit, or the sort of the tuning I had to do was I had to have one formula for the incoming, for the sort of upward signal, and then another one for the downward signal. All
This
sort
is
of.
JSFX.
So it's not JavaScript.
It's not JavaScript. JSFX stands for Jesus Sonic effects. Jesus Sonic because it started as a hardware project that was a guitar pedal, a programmable guitar pedal, and the physical construction of the prototype is like a box that was shaped like a cross.
Okay.
So Jesus.
Yeah, but
the most the interesting bit, I guess, it's the name of it. It's chokehold.
That's like that's a user.
Yeah, there's also the encoder chokehold. But I chose, as an honor to chokehold, I chose to name the limiter chokehold.
Another one bites the limiter.
Yeah.
Chokehold made a great DC blocker. I have shown it before.
Yes. I've got it in my library. But another thing, and that was what I was going to, if you're going to take a look at GitHub and how to upload on the GitHub page. What when you were talking about the Eevee and the glitchiness, and Cwits came up with that sort of hack where you did the calculation in a specific order. So what I changed in this, comparing the EMAs, I thought about, wait a minute, can I use that in that thingy? So I did the multiplication first and then the division, and then that weird sample spike disappeared.
Huh.
So that was great. Thank you, Cwits.
Inspiring everyone.
Yeah. So the old code would look like so. Yeah, if you remember, you helped me with this, Leandro. We muted the first sample, just to get rid of the spike. But this has actually solved the problem. I've tested it a bit, and it seems to work fine. So that's good to know. But what about we update the this thingy on GitHub?
Oh yeah, right. So did you install GitHub Desktop?
I didn't know there was such a thing.
Okay. So let's see if I get this right. You are interested in getting your code that we saw in Reaper back into GitHub.
All
right.
I want us that sort of commit stash, commit push, etc., the sort of the ecosystem of Git.
Sounds good. We can do
My
that.
original plan was to use the Visual Studio, but if there's a different way, I mean, how many different ways are there of using Git? 1,000?
5 million. And
also, you could create an index.xml file which can communicate with Reapack.
Yeah, and then there's Reapack, and then there's the stash.reaper.fm, and then there's the...
Yeah, what's your favorite way of using GitHub, David?
Of using Git.
Git in general.
And GitHub. So I tend to review my code locally.
Using your text editor?
In GitHub Desktop. And then I tend to generate a commit using an AI committing piece of software, because my commit messages are useless anyway. And then I tend to push it up to a pull request where I review my code again altogether. And that's pretty much it. And then whenever I need to do something like cherry picking or whatever, when I've messed stuff up, then I just resort back to the command line, because I know how to do like some basic things. So
fair enough. So your answer is GitHub Desktop. And that's what I recommend to Bo as well. I think it's a nice piece of software.
Sure.
So please install GitHub Desktop and jump through the hoops to sign in.
Wait, Bo, I just found an issue in your GitHub. You have uploaded the silent treatment 0.3, But when I went to your website, I had found 0.4.
Oh man, thank you for pointing that out. I will correct it ASAP.
Awesome.
So there will be some like boring work for you to do while you sign in, and if you have to factor authentication, you will have to maybe do that as well. So while you're doing that, do you mind if we pause, go to play the game that we are playing, and then we get back to you? How does that sound?
Absolutely. Just as a sort of digression here, but can you do all the sort of git, commits, push, etc. On the web page on GitHub?
You
can. That's better. Just tap edit there.
Yeah, there is a little icon on top of the code that looks like a pencil.
Let's see. I have Skype windows as well. Yes.
I mean, to answer your original question, no, you can't do everything. You usually say like, but you can if you just want to edit one file. Definitely, the simplest way is to just paste it in here and.
That's a good point. Yeah. And there is even github.dev or something. You know what I'm talking about?
Oh, where you like edit in.
It launches a Visual Studio Code session for you in the browser.
Yeah.
So that's another thing. Yeah, maybe that's a better workflow even.
Well, but then it's not local. Is that useful?
No, that is not local exactly, but you don't have to install a bunch of things. You don't have to sign up and sign in and blah, 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 two-factor authentication and all that. So great point. Just paste the new code there, commit the changes on the upper right button that is in green,
all right.
and that's all there is to it.
Oh man, this was lovely.
Oh, you don't even need to do that, but yeah.
I'm gonna just write Cwits hack.
Wait, I did it, not Cwits.
Awesome, because that was my plan to sort of just these are such simple projects with there's not a lot of files, there's not a lot of code, there's not a lot of. Why not use the web page? Right, it was that simple. Thank you very much.
What did Cwits do? He even asks in the chat.
Well, what's he saying?
What did I do?
You did you miss the part where I talked about the EWI?
Oh yeah, it was Cwits' idea.
Yes. So the glitch in the EWI, Cwits had an idea for that. Just move the code around a bit, and I added that, and I used that in the for my weird EMA calculations, and it works. It removed the sample spike.
Well done, Cwits.
Well, in my case, the hack worked, but not 100%. So we ended up using the library that Adafruit developed for debouncing, and that is great. It actually cleaned up the code because the library doesn't give you only the value, it can also give you, if you have pressed the button, it gives you not only the state, but also the event of pressing and the event of releasing the button. So it's even better.
Yeah. And thanks for pointing out the version of silent treatment. I will change that as well. Thank you for this.
No problem.
Yeah, I'm done.
All right. Sounds good. So Fotis, bring up the game.
Yes.
Let's play 1 or 2 levels and have some fun. So while he's bringing it up, the game that we have been playing on the stream for several weeks now is a modular synthesizer. It's a musical instrument that is a bunch of small modules, and the modules will do things like generate a wave, and the other module is gonna process that wave with a filter or distortion or things like that. And there are even some modules to do very simple computation, like gates, like not and or and so on. And in the real world, you buy these modules, they're super expensive, and then you can make music with them. This is emulating that. It's, of course, in the computer, and it is just pretending to be hardware, but you can draw cables around and connect stuff and all. And it's actually a game. So there is an input and an expected output, and you have to figure out what modules you need to provide or what modules you need to use to get to that output.
Okay.
So you're gamifying the learning of modular
Interesting.
synthesis.
By the way, before we begin, do you guys like Desmos?
Yeah.
What's that?
Do you know
Desmos
what's
is like an
better?
online
love
calculator
Desmos.
that graphs stuff. So you can, it's a graphing calculator in the browser.
Oh yeah. It's really good. It's the
Do
one.
you know what's
Mm-hmm.
Do you know what's better than Desmos?
Ice
There is
cream.
nothing better
Yeah.
than Desmos.
It's
Well, I know a
Desmos
bunch of
3D.
things, actually.
Oh,
Yeah, if you go to desmos.com/3D, they have a beta where you can calculate some more stuff in an extra dimension. You can even use the mouse wheel to make the grid larger or smaller.
Can it handle combinatorics?
The problem that we are working on together has to do with combinations of numbers, and it's just we are thinking of a hyperspace with it gets complicated anyway.
That's cool though.
So now that David is here, maybe he can help us solve this puzzle that we are stuck on for at least a month.
Oh, is this the next one down the line?
No, that's the one that we abandoned.
Okay.
And we had to go back, but we have to go in this one.
Yeah, we were doing the puzzles in order, and then we jumped ahead because we
jumped
didn't
to
remember
some-
where we stopped, and then it was too much. And then we went back, and we were working our way up to this. And I think that on the last stream we sort of learned the technique that we need to solve this one. So we are gonna attempt it again. Let's see if you can help us. So.
I can't guarantee much, but let's go.
So first of all, there is an input, or actually no, there is no input in this one.
Oops. Yeah,
There is no input on
you have
this
to
one.
create the input.
The output one is an alternating signal of constant frequency. So we have a clock module. Can you please just wire the clock module into the output for us to see what the clock module does? So this is our output in yellow. So the clock module is just generating pulses like that.
What's it doing?
It's just generating pulses like this.
Okay, like at an interval that you define.
Yeah. And then you can change this interval here, and it's going to be faster and slower.
Okay. But how come there are two?
Well, the blue one is the expected output. The yellow/red one is our output.
But why is there out one and out two?
Because we will generate another output. That is right now just yellow flat line. We are not wiring anything to output to.
Okay, cool.
But we are going to, and yeah. So do you have a grasp?
Basically, we need
Yeah, I got it.
Okay.
we need to turn the blue lines into yellow. You don't need any red lines anywhere.
Okay, so out two is
It needs-
not too dissimilar to a clock, maybe. It looks.
Yeah, out 2 will be described here later on. It alternates between two clock signals with different frequencies, so on and so forth. But let's try and get output 1 first, because usually output 2 depends on output 1.
So can we make the top of the clock longer? Do we how much?
Yes, we're gonna go up to 5 intervals, but even that is not enough because we have a sample and hold. And the voltage
let's
control
get to that in a
amplifier.
second. But let's see the output of the clock with interval of 5. So the thing that I see is that the clock always generates pulses of the same width. It's always one, let's say, one beat.
Yeah, how can we increase that beat length?
Yeah, what we want is to not only change the time, but also change the length, right?
Yeah.
So that's where we got stuck last time. But I do have an idea that involves the next module down the line, which is the sample and hold. Do you know about latches? because that's what it is.
In databases, yes.
No, like a flip-flop.
Ohi.
Huh?
Ohi.
Oh my God! You said no in Greek.
No. Ακριβώς.
You know Greek?
Very limited, very limited.
Okay. You know that I am Greek, right?
Yeah, I do. Yeah. I just thought I would light up your eyes.
That caught me off guard, but yeah, it did. My eyes are always lit up, but
Nice.
Or actually,
I have black eyes.
if you don't mind me asking you to do a lot of things, instead of doing the sample and hold, can you please split the signal from the clock and pass one half of it through a NOT gauge? So a signal splitter is just what it says on the tin. It's like an extension cord for the signal. It's just giving you multiple copies of the same signal.
Got it.
Then the NOT gauge is pretty much what you expect, right? It's just inverting the clock.
Okay.
Perhaps you want to wire, just so we can see what's happening. Can you wire the NOT output and the split output? So just one of the signals from the splitter. So we will see.
Oh, like this?
Yeah, like that. So now output 2 is the clock.
Target?
Huh?
Can we do it without the target? So that's like...
Oh yeah, can you turn off the expected output? Is this something that...
I don't remember how you do it.
That's okay. Okay, that looks a bit better.
Oh,
yeah, so we
I
can
have to
see that
turn
the
off
yellow
this.
line is up and the yellow line is down, and yeah, it's all right. It's just inverting the signal, right?
So yellow is good, or blue is good.
Blue is what we want in the end, but never mind that. We are dealing with the
Do you
yellows
see
and
the
reds.
sounds?
Or maybe, Fotis, do you have the oscilloscope? Maybe we can use the
Yes.
oscilloscope
Oh,
instead
yeah.
of the outputs. There you go. Right. So now we can see that the yellow signal is the opposite of the blue signal. And
We're
this is
nulling
where
them.
I
Null
think...
test.
Sorry?
It's like a null test.
Yeah.
Because we'll have inverted the phase.
Exactly. So I think that with that, we'll be able to go to the next step, which is the sample and hold. And a sample and hold is bringing the module, and I can explain the ins and outs of it.
So let's do it.
Right. So a sample and hold has two inputs. The first is a signal that may be changing over time, like going up and down like crazy, and it doesn't matter. The sample and hold is not going to look into the signal until you send a gauge. A gauge is a rise in the signal, so it goes from 0 to 1. As soon as it goes from 0 to 1, it is going to look into the input, and it is going to store that input, and it's going to make that the output. And then it's going to stop looking into the input again. So it's a way of sampling what the input is and holding that sample
For an interval.
for however long you take until you send a gauge again.
So how do you... So if the gate is active, then it will output the input?
Yes. When
And then-
you... And a
If the
gauge
gate
is like
off, it will output nothing.
it will output whatever it was outputting before. It will remember that. It will hold that sample and it will continue outputting that. So if the input is 1 and the gate is activated, the output will be 1 until the next time you activate the gauge.
Okay.
If you want me to visualize what sample and hold looks like, imagine like a skyline of skyscrapers, like buildings. Because you're sampling one value and you're holding it. Then you're sampling a different value and you're holding it. And you're sampling a higher value and holding it. So you can draw like buildings. And also, do you know the most famous example of sample and hold? And everybody knows, everybody has heard the sample and hold effect, but they don't know what it is. And it's this guy.
is
So
this?
the R2D2
Oh,
was literally created with sample and hold because the sound designer of Star Wars, Ben Burtt, modulated his own voice in a synthesizer, and he sampled and held his own voice. So those robotic stuff is exactly that. It's
Interesting.
holding his voice for specific intervals.
ah.
That's fascinating. I didn't know that. All right. So
That was a great imitation, though.
Right.
I have sample and hold in here. So let's listen to this signal. Let's check out the signal without any sample and
So
hold.
I guess the plan is that you're going to sample while it's active,
So yeah.
and then gate it on when you want it to be constant. Are you going to sample something different to the clock?
Yes, we are, in fact.
well, I was thinking of using the clock as the gauge.
And
And
we're gonna sample output 1. No, sorry. Please go on.
no, I was thinking of using the clock as the gauge. And we don't just want any clock, we want like a specific number on the interval, but I forget what the number was. I think it was 4. And then as the input, I think that what we want is the clock negated. I think that's what I thought about. I'm not sure if this is gonna make any sense, but can we try that? Clock to splitter. One of the outputs of the splitter into the gauge, the other output into the notch, and the output of the notch into the input. Yeah, that.
Let's hear it.
Let's visualize it first.
No, it's just flatlining.
Yeah, it's flatlining because it's nulling itself, right?
Yeah.
Even as a gate. What if we change the number? Nope.
Okay.
What if you do the inverse? Just invert the output of
The note is doing that.
the output of the not to the gate and the output of the clock to the.
Oh, okay. I'll change it. But I think it's gonna give us the same.
Yeah.
Yeah, it's the same. We have and or and not if you want to experiment with that. And the other thing we have here is the voltage controlled amplifier.
You can think of that as
It-
multiplication. So you're not dealing with zeros and ones anymore. You're dealing with -1 to 1, but in all numbers in between. So
How can you
floating
get to
point.
-1? Oh, and everything in between.
Yeah, and everything in between,
Yeah.
as in like floating
Oh,
point
okay,
numbers
okay,
instead
okay.
of binary. And
Yeah, and CV stands for control voltage. So
Yeah.
if you put an input in here, you can choose the percentage of the input. You do multiplications here. Or if you do a not, you can do division.
Do we have just like a plain input?
In this one, no, we don't. We have to create it. If you want, would you like to choose a different, simpler puzzle instead?
No. I wonder if we can create a flat line, then we should be able to create an up line. Right? Fairly
Yeah.
trivially. So if we can have the up line, then we can use that as maybe the input or the gate. But probably you want to sample that up line, right? And then you just activate your clock and then.
I don't know.
No?
I don't know. Go ahead. Try it.
Well, I guess the first step is to get just a straight up line, a 1. I'm not sure how to do that.
I thought about it in some situations. I wanted like just a 1, and we don't have one. And I guess if you take the output of the notch and you don't wire anything into it, it may be a 1.
Or if we use an end.
Yeah, I don't know.
If you
or a sum.
Or if you don't knot it, if you don't knot the output of the clock from the splitter, then put that as the other What does it give you?
Oh, that's an outline. All right.
Is it? Isn't it flat?
Yeah, because if we turn it out, now it's flat. But if we put the gate and the clock at the same time, now it's an outline.
Huh?
Oh, sorry, I'm looking at the bottom bit. I'm not looking at the oscillator.
No,
Yeah,
I'm
the
I'm
oscilloscope
pointing
here.
at the oscilloscope. Yeah,
Yeah.
I'm gonna do it again. So this is without the gate, and the line is flat, as you can see here.
Yeah.
But if we gate that and also input that, boom, it's an outline now. So you were correct.
Somehow. Button bashing got me there.
Brute force.
Yeah, brute force it. Yeah. I mean, how many combinations of... Oh, dear.
And this is the fun thing about this game, is that there are many solutions to each puzzle. Like, there isn't one way. And in the Discord server, you can post your own solution and compare it to other people's. And in fact, there are challenges on how to do the most elegant solution, the simplest solution, the less module solution, the shortest cable solution. Yep. But the way you can do it by putting the output right here. Haha. Now the cables are shorter.
Okay, so we have an up line and a down line. And now we just need
And
to...
a flat line.
Sorry, yeah, an up line, like a 1 line and a 0 line. And now we just need to find a way of flipping the gate at the right time.
Huh. Why are you looking at me?
Can I propose something different?
Yeah, of course.
Okay, get rid of the notch.
I did.
We are getting rid of the notch for now. Oh, you already did that. Excellent. So take the signal from the clock and split it. That's all right. Then give us 2 sample and holds. Not just 1, 2. Connect them in series. The output of the first is the input of the second. That's a weird way of wiring it. But anyway. And
Sorry. I don't know.
whatever. I can follow the cables. And then the gauge is the same in both. Yeah, that makes me happier. But anyway, the gauge is the same for both. It's just the clock.
Oh, so like this?
Yeah. And then for the signal that comes into the first sample and hold, how about we have another clock with an interval of 2?
Sure. Why not?
And try that. I want to see what that looks like.
Okay, so where should I be looking here?
It's a flat line again. Jeez Louise.
No, it's an outline, not a flat line, but an outline.
Yeah, but I mean, it is still like a flat line. It's not coming up and down.
Yeah, and it's
And
not
the output is here in the
modulating.
oscilloscope on the first line. So you see, you come here to the splitter, then you gauge, and then the input of the second clock is going, or the output of the second clock is coming here. The output of
Oops.
the output of the first sample and node is going to the input of the second, and then the output is going to the oscilloscope. Okay.
Yeah, so why is it flat?
That's an interesting question. Can you like tweak the intervals? And I don't know what I'm looking for. Just tweak them and see what happens.
I put 3 in both.
Yeah, the same number in both
4.
doesn't sound too good.
Oh, wait. We have some movement.
We have some movement. Okay. So I think that maybe with the with a bit of luck, we may get it. Can you put the output of the oscilloscope into the output 1?
Oh, we are getting somewhere. We just need to make this slower. Like half, 50% slower, and we're gonna solve this. Yes.
Yeah, so can you like tweak the numbers some more and maybe we'll get there by happenstance?
Yes. Let's
Try
let's
make
do
it. Try and make one of them really long.
The longest is 5.
Oh,
Oh, that's cool. So
Yeah.
4 there seems cool. give it a 4 on the
Okay.
second one. Yeah. And then tweak the other one to be like a...
Is there no 1?
Oh. What about 4 and 4?
That's gonna flatline.
3 still flat. No. Yeah, I think that's
Is
the
it-
closest we've gone so
So
far.
is there no 1 on this dial?
No.
No.
So
starts at a prime.
rinse and repeat. Another sample and hold. The output of the second goes into the input of the first. Yeah, you know what I mean. Just chain them.
Like this.
And yeah, that exactly that. And then
Let's get another clock involved.
do we want the same clock
why
or a
not?
different one? Let's start with the same one. Let's just get it from the splitter.
Okay.
Okay. we'll get there. No.
This is so bad.
Oh god. This is driving me nuts.
But it is cool, right? We are chaining the sample and holds, and we are able to get different intervals.
Oh yeah, by the way, David, the first time we played this game, Leandro was calculating how much money would all this cost if we did it with real modules.
Yeah.
By the way, this game actually has a story. Like you have characters and you talk to them with messages. You have hints as well. And the story is it's set in the near future. It's a post-apocalyptic world. And you have to create these modules in order to save the world.
Nice.
But but Leandro said that the irony is that the world has been destroyed and their fate relies on these very expensive machines.
Yeah.
So let's look at the hints.
You need to store the clock pulse in memory for out 1. So that memory that it's talking about is the sample and hold. It has some memory there. Use sample and hold modules to store the clock pulse and hold it and emit it over multiple timestamps. Use sample and hold to store the clock pulse and emit it over multiple timestamps. You can use logic modules to toggle between toggle signals of different intervals.
Oh yeah, that's what we did last time. We used an XOR gate to modulate what was going in the output 1, right? We could do something with these 3 doohickeys.
True.
We just need to find the correct combination.
Fotis, give us the next one in the chain that we
Wait,
were
hold
working
on.
on, so that
Oh.
we have a quick win
Wait.
here.
David has an idea.
Well, just the fact that we're like cancelling out the signal,
Mm-hmm.
it just feels very suspect to me. Like we should be able to like exclusive or it, and it should just work.
Yeah, an XOR. We did it last time, but I forget how we used Ender or not.
Like just
in series.
like you have one which is coming through. When we did the cancelling out thing,
Mm-hmm. The nulling, yes.
the nullifying, it was because it was knotted,
Mm-hmm.
and it was being sampled when it was like empty, right?
Mm-hmm.
And then when it wasn't empty, it was like the low signal of the clock. But when it was being sampled, it was the low signal. So what was happening is it was like, okay, right now, let's look at the expected signal again. So the
We
expected
can see the
signal.
breakpoints.
Yeah,
We
so
have-
so it has to start with active, right? So the gate has to start off. So it needs to start sampling. Right?
Fair enough. Yeah.
Then the gate needs to be active. But the issue is during that time period, Wait, the sample and hold. How does the duration made?
The sample and hold will hold when, or actually it will sample when you send a gauge, and it will hold that value until you send another gauge.
Right, so what we need is to play some sound for 1 beat, and then get the sample and hold to continue playing for 1 more beat. Then our clock should be off. But by the time it's off, it's already back on, right? That's the issue. Like, our sample is the same duration as our, like, interval at the moment. Right? Is that right? Is that always the case?
Our sample is the same duration of our interval. No, the sample is instantaneous. In the sample and hold, it's instantaneously sampling when
the hold,
the signal.
The whole
rises.
duration is of the same length as the duration of the clock interval. Is that always the case, or why is that the case?
The whole duration is the same as the clock duration, because when the clock goes up again, it will sample again.
Okay. Because what we need is for it to hold for longer than the sample.
Yeah, we essentially what we are doing is trying to divide the clock.
Because if they're always the same, then they're always going to be either fully on or fully off. I guess. So could we just have the second clock? But then as soon as you have a second clock, they become out of sync.
Not always, if the intervals are multiple of each other. Or even if they are not multiple of each other, they will go out, they will drift off and come back together every time that there is a common multiplier.
Yeah, it depends if they'll drift off in time.
Yeah.
Okay, no, I don't know. I thought I had an idea, but I don't even
Let's go to a different puzzle.
Yeah, maybe. But can I try one more thing? I know. But I want to try one more thing.
Sure, let's do it.
Yeah. So what I want is to bring in that notch that you have and split get it from the splitter. The input is coming from the splitter. Drop the second sample and hold like we had before. And this time, the clock of the second sample and hold, the gauge of the second sample and hold, comes from the output of the notch.
Oh, yeah. So we're flipping that.
Yes, so we are not sample and holding all at once. We are creating a cascade. What does that look like? Oh, I guess we need to wire the output of the first sample and hold into the input of the second to create the cascade.
Yeah. Do we have to get rid of that clock?
No, keep it.
Okay. Oh.
Huh.
We are getting somewhere.
Can you tweak the knobs? I'm crossing my fingers here.
We're gonna do some brute forcing. Come on.
When the numbers are the same, that doesn't work. So maybe do 2-4 or 4-2.
Oh, 4-2, I didn't write it.
Explain again, sorry, what are we doing, Leandro?
Geez. So what we're doing now is that previously we had a cascade of sample and holds, right? And all the sample and holds were being gated at the same time. What we are doing now is that they are going to be gated out, creating a cascade. Like the first sample and hold is going to be activated, and then the second sample and hold is going to be activated. Because they are getting gates that are inverted signals.
So the gate of the first one is the first clock. And the gate of the second one
is the first clock negated. So when the first clock goes up, the first sample and hold activates. When it goes down, the second sample and hold activates.
This could work if we now paired it with our like flatlining up and flatlining bottom.
Perhaps.
Like now that you have like activate this one, it seems very complicated though.
Can you bring in a third sample and hold that has a clock? The third sample and hold has as in its input the output of the second sample and hold.
So another cascade.
No, the output goes into the input, not the gauge.
Oh, okay.
And the gauge comes from the first clock, from the splitter, basically, from the splitter. Let's see what that looks like. Jeez Louise.
Oh. So we did what we wanted, but only once.
Yeah.
If I do it like this. Oh. We did something similar to what we did before. We get closer. Oh, please. This is getting out of hand.
Yeah. Anyway, this was fun. Do you want to play a level that we can actually probably get?
Yes.
I think
Let's
I've been
go.
nerd sniped. Just gonna be thinking about this.
Now
one.
you know how it feels like.
That's what I
Let's
like
go
about
back.
my friends.
We're sniping each other. Like any nerd should.
It's an ongoing conflict.
Yeah, but you know that there have been so many divisions of the nerd. Like there is the nerd like us who is creative and studying and doing stuff. And then there is the nerd who sits around and plays video games and eats junk food. They are doing so many different versions of what a nerd and what a geek is. And frankly, I'm just tired of all of this.
We are the OG nerds.
We are the OG nerds. We're the best nerds. We're saving the world. Remember what was the first thing I told you, Leandro, ever? I told you, you're saving Reaper. And you said, from what? And look where we are now. We have saved Reaper. Let's do the radio clocking system. I think we did it again, but let's do it just so we can refresh our memories. And this one actually has an input, but it has the clocks as well. So we can get a deeper understanding of how the clocks work in a simpler way. Oh, this one doesn't have an input either, but this is easier. So, and we solved it. I think I remember how we did it, but let's do it step by step. So this is what we have to create. Fourths, seconds, and thirds. No,
So the
this
first
is
one
the
should
fourth
just
again, but
be-
it's inverted, sorry.
So the first one is just an interval, just like a basic clock. I think it would fit
Yeah.
on a, like 2, maybe.
Yes, this is 2.
Okay, cool. And then
The second one is in 4. No, it's 3. Boom. We solved it. And then the second one is the same as the other one, but inverted.
okay, that makes sense.
So we have to invert this. Boom.
Very satisfying.
This is how satisfying it is.
Okay, cool. Nice. I like it.
Oh, what was our score? Oh, 17,000. Let's go to the next one more, and then we turn it off, okay?
Yeah.
All right.
Sorry, it's taking a while to load the levels. By the way, there are not just clocks and stuff, there are other things. For example, most of the puzzles already have an input, and then you have to create another one. Let's check this one, the radio memory buffer. Ακριβώς. So this one has an input and an output. So output 1 receives memory buffered signals from source 1. Oh, we're using sample and hold again, but this time we're gonna use a source. So this is the input.
Not.
At regular intervals, the memory buffered signal is updated to the latest signal from source 1. So, and we have some notes on the bottom. Clock modules output trigger signals, we know that. So we have to modulate the sample and hold using a clock. So if we do it without a clock, it goes like this.
What?
I didn't use the clock, I just plugged in the input and the output. But if we put a clock in the gate, it's playing a melody.
Groovy.
Wow.
Yeah. And if I had the music turned on, that sound would be on the same key as the background music. It's super harmonious. But I have the music turned off for copyright reasons. But anyway, you got the gist of what we're doing, and so you have to brainstorm for the next meeting when we're gonna crack that case.
Okay, εντάξει.
Εντάξει. Ακούγεται καλά. Sounds good.
Ναι, να είστε καλά.
The camera is just it's cutting our heads. I would slouch.
How did you learn Greek, if I may ask?
My ex-girlfriend is Greek, so went to Greece quite a lot, yeah.
Oh, okay.
Yeah. Well, I can't say I learned Greek. I'm just very good at pretending. Like I was teaching Leandro how you say yes and no in Greek. How do you say no in Greek?
I don't remember.
Oh. I give you a hint. Oh.
No. This is not how you say no in Greek.
No, I'm just giving him a hint.
No,
he can remember.
but this is incorrect. You don't make a sound.
I think it's like
Yes, it's this.
Or this.
Just the eyebrows.
Yeah, the eyebrows. Yes, it is one of the many ways. We have a lot of ways of saying no.
Yeah.
I wonder what this tells to the world.
But you have many facial
are
expressions,
negative
which I really like about Greece. Well,
all right. Shall we wrap up?
let's wrap up.
Yes.
All right. So, do we have like a no here? All right. So, first of all, let's say hello to people if we have people here on the chat, which last time I checked it was Bo and Cwits. So, thank you, Cwits, for joining us, and thank you, Bo, for joining us. And thank you, Fotis, as well. And, of course, my special guest, David. I love that I have in real life guests here. It's amazing. And I am looking forward to seeing you next time for the C++ Digital Signal Processing and JUCE study group meeting. Have a good one, everyone.
Bye.
Bye.
Take care, everyone.
Keep studying, keep making the stuff you love. Bye.
Thank you for watching the stream, you know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all be back together for some more coding or talking or chilling. The next time I'll be streaming.